if you want something on page, out of the homework, out of page 195, on the website, whatever, let's spend a little bit of time here going through some derivative problems, and then, just talk about how the gateway test and everything, and then give you some practice time too. What do you got? Must be a short review. Problems, I'm gonna see, maybe we should just take the gateway right now. Okay. Number 11 on 195 on the homework. Cosine of the arctangent of 2x. So y equals, or no, that's not derivative, is it? That's the, rewrite it as an algebraic expression. So that's that triangle thing. So that's that triangle. And again, not a big deal for tomorrow, but arctan of 2x. Arctan of 2x means the angle whose tangent is 2x. So tangent is opposite over adjacent. So that would be this, right? And so we do Pythagorean theorem, which would be 1 squared plus 2x squared, which would be that, equals the hypotenuse squared there. So it would be the square root of that. So this would be the square root of 1 plus 4x squared. So then it wants us to do the cosine of that. So cosine would be adjacent over hypotenuse. So it would be that. It would be that right there. That's what we want to do on the left. So yeah, that was just, because you remember doing these triangles was kind of how we got our derivative rules. But let me get into the derivative rules. So if we want to look at like 13 on down, if we want to look at one of those, because remember we're talking about these 3 derivative rules right here at the end. I probably should just mention this right away, number 21, because a few people have asked me about it, and I know. Why would I put on here arcsecant, and it was x over 2, I think. Why would I put that on there when that was not on the rules I did, right? Yeah, you could change it to arc cosine. This is exactly the same thing as that. Those two are the same thing, right? Because now remember, arc trig functions, you interchange the x and the y, right? Cosine and secant have reciprocal values, right? Reciprocal outputs for cosine and secant. So that means arc cosine and arc secant have reciprocal inputs, because the inputs and outputs are interchanged. So that's why we can flip the input when we do this. Okay, well then that would just be, we would just rewrite that as arc cosine of 2x to the negative 1 is how I would do that. That's y. So y prime would simply be 1, arc cosine's negative, square root 1 minus this all squared. Now you wouldn't have to write it like that. You could write it 2 over x still, but I always like to do that. Times the derivative inside, which would be negative 2x to the negative 2, right? When you do the derivative of the inside, like that. Now, you should probably put that up on top, so that'd be positive 2x to the negative 2 over the square root 1 minus, wouldn't be a bad idea to square that, so that'd be 4x to the negative 2, and then I just say leave it. I don't care about those negative powers and the rest of that. And so it's going to look a little different than the back of the book did, I'm sure, okay, because the back of the book probably did some, probably moved this down to the bottom here as an x squared. It probably did a little messing around with that inside to make that look different, but that would be good enough. That would be good enough. Okay. What else?
61.
61. Yeah, I wouldn't go any farther than. I wouldn't even go to 61. No, don't even worry about it. Now 55 we should be able to do. Okay, here's why on 60 and 61. Because those have x raised to x. We have a rule for x raised to a number, and we have a rule for a number raised to x, right? But how do we do x raised to an x? Well, number one, that function, those functions don't even ever exist anywhere that I know of. It's one of those made up things that we have a way we can handle. Here, let me just tell you what we do. I'm not gonna, because you might get to a college class where you have to do it, but I'm not gonna ask you what. So 59 is where I would stop. Okay, on page 195, I would stop at 59. But it says y equals x on x. What do we do on this? What we do is we do the log of both sides. We would do the log of both sides. This is what your college instructor would tell you to do. Okay? And then what can you do, and what does that allow you to do when you have a log over here? Well, you can't cancel, but you can bring the log down. You can bring the exponent down in front. And then you don't have that exponent anymore. And then you have to do implicit differentiation. Then you have to do implicit differentiation on both sides because you don't have y equals them. That's how you handle x raised to an x. But we're not going to have that. We're going to have a number raised to an x or an x raised to a number. So in 55, we got y equals e raised to the x over sine x, like that, right? Okay, now this could very well be one that we do for sure. Okay, well, what rule is this? This is e to the u, right? Which is e to the u times u prime. So so the derivative of this is going to be e raised to the u, so it's just going to be this by itself, times that. Well, what is that? That's a quotient rule, right? That's a quotient rule. So this is a good review of the quotient rule. So the quotient rule is derivative of the top is 1, leave the bottom alone, minus the top left alone, times the derivative of the bottom, all over the bottom square. And that's it. And there isn't anything you could really do to that. I mean, you could, this over 1, put it up top, but nothing would cancel, nothing, I mean, that's it. And that will be a fair number of them on the gateway test. So, I mean, we're going to talk, sure we'll talk a lot today about some simplifying and some canceling, because there could be some on them. And you might have to do that on 2 or 3, but not 7 or 8 of them, right? If you're looking for things to cancel and things to combine and stuff like that, right, on every problem, you're trying too hard. Okay, you're looking for stuff that's not there. Now, I'll admit, on the quotient rule, that's a lot of times when you can do some of that. Because a lot of times on the quotient rule, you can combine some stuff on top or factor out something, maybe cancel, right? That's when you can do it, but there just isn't anything there. There's nothing to cancel, there's nothing to factor out. You just can't do it. If you really reach, if you're really searching for something, you could split this apart. You could do sine over sine squared. This is not necessary. You do not need to do it, but you could, right? Then this would cancel one of those, and you'd have 1 over sine. If you really, really wanted to search here, you could split that, and one of them would have something to cancel, one would, but I wouldn't worry about it. Okay. All right, good one. What else?
How do you know for sure when you use the product rule and the chain rule? Because when I tried to solve them on 195, I kept getting things.
Okay, could you give me an example?
Like number 7 on 195, I tried to solve that by using
Yeah, that's a good one. Now I'm going to change those into x's here, just for the heck of it. But okay, so this is e to the x squared. Now we said whenever we see that, we think of it like that, right, with the parentheses. And then times tangent, and then what's that, x to the 1/3 inside, like that. Okay, so the question is, you said product rule and chain rule. Well, they definitely have stuff on the inside, right? But first and foremost, this is a product rule, because what you have here is you have a u and a v, right, like that, right? So this has to be a product rule. So that would be u prime v plus uv prime. So that's what you did? You said product rule. So what's a product rule mean? It means do the derivative of this first, right? So the derivative of this would be what? close. It'd be 2x. Because remember, it's a derivative of the inside, right? So again, so I'm ready to do this, right? And so right now I'm just working on this. I'm working on just the derivative of this. Well, that is e to the u times u prime, right? So you got to think about the different rules. So first and foremost, this is a product. It's this times this. So the product rule is this. So that means I'm going to do derivative of this. Okay, that's e to some stuff. So it's e to the x squared, right, times 2x, derivative of the inside. Then times the v, which is this part, left alone, right? Plus, now it's the u part, this part left alone, times now the v prime. So now I got to do the derivative of this. Well, that's tangent of u, right? Tangent of some stuff. Well, what's the derivative of that? It's secant squared u times the stuff inside, right? So this would be secant squared x to the 1/3 times times the derivative of the inside. The derivative of x to 1/3 is 1/3 x to the negative 2/3. Does that make sense? So what part of that, or where were you going wrong? Just maybe on your chain rule, your derivative of the inside part?
I'm just getting confused, like, when you use the chain.
The chain rule, do you notice how I said that? I first said, okay, this is a product rule, which is this. So now I'm focusing on each part. So now I'm just focusing on this. Okay, so I'm just focusing on this right here. Well, what is that? Oh, that's e. The chain rule is just when you got some stuff on the inside. So you got to look at that and say, oh, that's just e to the u. That's e to the u. What's the derivative? What's the rule for e to the u? It's e to the u times u prime. Right? So you know what I mean? So you just break it down one bit at a time. Now, what's left on that one? Anything to simplify that? Really, it's just rearranging. I mean, because look what you have. When you step back and look at this one, it's really just those two things added together. So all I can really do is just rearrange. Like I could bring the 2x up front, but I wouldn't worry about that. This I could bring. Now, if there was a 6 out here, and this 2, the 6 times 2, I'd want to put together and make it 12. Right? But there's not. So I would just leave it. There's nothing to do. Right? You're done. You're done. Okay? Good one. Good one. What else? Here's a good one. If nobody's got another one real quick. This would be very much like what you were just asking about, 43. Did you try 43? Y equals, let's try 43, ln of e to the 3x plus sine squared x. Now I'm going to give you a caution, that's sine squared. Remember that you have to think, okay, take a minute to do this one. Take a minute to do this one. Don't forget, when it comes time to do that sine squared, you got to think of that as sine x all squared. this one would be on the hard end of the scale too, because there's just a bunch of stuff in there. Now, to be honest, the last one, that's, to me, that was in the middle more a little bit, just because it was a pretty straightforward product rule. It did have those chain rule elements, but it didn't really have any simplifying or anything you had to do. I guess what I'm saying is to get 8 out of 10, you're probably going to have to get something like that one. Now, how's this one start? Well, this is ln of u. Isn't that really the rule on this one? What's the derivative of ln u? Times u prime, right? It's 1 over u times u prime, right? So the u is all this stuff in here. So it's got to be 1 over the inside left alone, which is this right here. That's the part some of you were having some trouble with, is you were wanting to put this out here again. No, it's when you write it down here, that's when you're leaving the inside alone. Right there is when you write it down there. And again, really, you should just remember this rule. The rule here takes care of the chain rule for you. That's what this u prime is here at the end. So if you just remember the rule, you got it. So ln u is 1 over u times u prime. So we got to do u prime, which is the derivative of this. Well, it's a plus sign. A plus sign, you do the derivative of each part. Now remember, here is where we got to have these parentheses, because we're doing the derivative of this inside, which we got to multiply by. So if you don't have parentheses around this, you're in trouble. But it's a plus sign, so that means we can do each part individually. So what's the derivative of e to the 3x? 3e to the 3x. Now that's because it's like e to the u, so it's e to the u, e to the 3x times u prime. Derivative of 3x is 3. Plus, here's the one we really mess up. What should this be? No. Well, yeah, it should be. Yes. Yeah, I'm sorry. I meant what's the derivative? Yeah, that is that. Right? Sine squared is this. So what do you got for this derivative right here? 2 cosine x? 2 sine x cosine x. You got to bring the 2 down in front.
Wait, is the cosine x squared?
No, there's nothing squared. Because look, again, what is it? It's sine of x all squared. Right?
Yeah.
How do you do the derivative of that? What rule is that right there? Well, they're all chain rule, right? I mean, what's on the rule page? They all have that u prime. What rule is this? This is u squared rule, or the u to the end. And so what should that be? That should be 2u to the first times u prime. That's what it should be. So it's 2 down in front, sine x left alone. Now I'm not going to put parentheses around it because it's just going to be the first power, so I don't need it. So it's going to be 2 down in front, sine left alone to the first, times the derivative inside. What's the derivative of sine? Cosine. We miss this one all the time. All the time. But I think if I'd have written it like that for you, I think you'd have got it more often. But it's 2 sine x cosine x, because it's a derivative outside. So it's the u squared rule. Bring the 2 down, leave the sine alone, times the derivative inside, which is cosine. Derivative sine is cosine. So there it is. And again, there's nothing we can do to that. I can grab these parentheses, stick it on top, but that's it. I mean, so I would just stop right here. Make sure you have parentheses around this here. But okay. And again, I say that's one of the harder ones. It shouldn't be, because there isn't a ton of simplifying or anything. But there's just a lot of little places. That's why I said to get 8 out of 10, you've got to work a lot of these problems, right? You just have to. All right. What else? Let's keep going. Keep going.
Was there one on there that would be like one of the hardest sections with a lot of simplifying?
Somebody had one. Somebody came and asked me about one this morning. I wonder if, oh yeah, number 4. Yeah, number 4. y equals x over the square root of 1 plus x squared. This one right here. The ones that are a mixture of like e's and signs, or, you know, a lot of times those don't have that much simplifying, but you never know. And I can make one up here that would have a little bit of simplifying. Okay? All right, so go ahead and start on that. Go ahead and start on that. Now, the first thing I would do if I was doing this is I would make it this, and then I'd go 1 plus x squared to the 1/2, like that, right? Now, could you bring that up as a negative 1/2 and do it as a product rule? You could. I think quotient rule is just as good. I typically, on one like this, I just do a quotient rule, right? If you wanted to bring it up and do it as a product rule, we could do it. It might be worth doing. Maybe we'll do it both ways. It'd be good practice. All right, before you get too far into the weeds and see how you did, let me show you what I got for the first part.
Do you need parentheses or anything? 1 plus x quantity squared.
Isn't 1 plus x quantity squared?
Isn't it b squared?
It's the bottom squared, but the bottom is a square root.
I just looked at 1 plus x quantity squared.
Well, it's 1 plus x. It would be 1 plus x squared to the 1/2, all squared. But when you have a power on a power, you multiply. So that would just make 1. So it's just 1 plus x squared to the first. Yes, it's v squared. You're right. It's the bottom squared, but the bottom squared would cancel out the square root, and so just 1 plus x squared. Okay, so we got two things we're talking about in this problem. We're talking about the simplifying, but of course we got to get the rule right. don't we? And there's, hey, I'm not gonna lie to you, there's some problems. We gotta have some algebra in there, right? There's some that's just gonna be the straight derivative rule, but we also have to be able to do some simplifying too. Because where we wanna eventually use these problems is we wanna do the derivative and set it equal to 0, and we wanna then solve it, right? I mean, so we've got, and especially in a no calculator, if it's a calculator problem, we can let the calculator do a lot of that work for us. No calculator though, we've got to be able to do the derivative, we've got to set it equal to 0. And then to solve it, we want to get it in a form we can work with. So now if you all agree with this, you okay with it now so far? Derivative of the top is 1, we leave the bottom alone, minus the top left alone, the x, now the derivative of the bottom. Well, the derivative of the bottom, we have to bring the 1/2 down, leave the 1 plus x squared alone, drop that to negative 1/2, and then times the derivative of the inside, which is 2x. And then all over, and then we talked about that. Now, what can we do on the bottom, on the top here? Well, I can take this 2 with this 1/2, right? Cancel that. Excuse me, I can take this x times this x and make x squared, right? So that's what I've done so far. So I end up having this right now, right? So that was a little bit of simplifying right there that I did. Okay, now, what more can I do? There is some more.
Take the powers.
What do you mean?
You can take 1 to the 1/2 and x to the first term on the top.
No.
So you let the top and the bottom.
I'm going to pretend I didn't hear you say that. Right? Isn't that what we have here? Which, of course, we all know that would be 25, right? You cannot distribute a power. You cannot distribute a power. Because that's what you'd be doing is distribute, right? You cannot distribute a power.
You split the top, so make it 1 plus x squared going up over 1 plus x squared minus.
Yes, that's not a bad thought. That's not a bad thought. Let's do that. Split it. I was thinking another direction, but I'm going to put yours in red, and then I'll come back and show you what I was going to do. Let's split it, and so we get 1 plus x squared to the 1/2 power over 1 plus x squared. Let's face it, that's 1 plus x squared to the first power, isn't it? Right? And then minus, and then here we have x squared, and we have 1 plus x squared to the negative 1/2, and then over, and again, 1 plus x squared to the first, right? So what can we do with those powers?
Subtract.
So 1/2 take away 1/2 is 1 plus x squared to the negative 1/2. Minus, then we'd have this x squared here, and then what's negative 1/2 minus 1? Negative 3/2. And then you don't have really a fraction at all. That doesn't simplify quite as nicely as it could. But you know what? I don't know. I don't know if I would go with, I don't know if I would accept that one tomorrow or not. Because I told you, I'm gonna, be kind of picky on, you're gonna get 30 out of 30 in the grade book, so you gotta earn it. You gotta get 8 out of 10 pretty nicely. Here's what I was gonna suggest. Let me do it in blue. What I was gonna suggest up here is I have a common factor of this 1 plus x squared. Okay? Now, because this is gonna come up again later this year. If you have x to the 5th minus x to the 2nd, what do you factor out? An x to the 2nd, the smaller of the two powers, right? It's the one they have in common. And then what's left? X to the, and how do you get a 3? It's 5 take away 2, right? You had a power of 5 and you took out 2 of them, so it's 5 take away 2, so you subtract the power. We can do the same thing here. Which one of these is a smaller power? The negative 1/2. We can take out a 1 plus x squared to the negative 1/2. Now I'm going to use square brackets to show what's left. But, so what would be left? Well, if I had a 1/2 power, and I took away a negative 1/2 power, what's that? 1/2 take away negative 1/2. That's a 1, right? So that leaves me 1 plus x squared just to the first power, which is nice, right? That it's to the first power. Minus, and then what if I take this out? That's gone, right? And what's left? And then on the bottom, I still have my 1 plus x squared down here. Now, what happens inside my square brackets? The x squareds cancel. And you end up with just 1 in the square brackets, which, of course, is basically nothing. And now look what you have. I'm going to have to come way back up here. Look what I got. I got 1 plus x squared to the negative 1/2 all over 1 plus x squared to the first. Now subtract those powers. So take negative 1/2, subtract 1. Negative 3/2. So 1 plus x squared to the negative 3/2 is my complete answer. It simplifies all the way down to that. Okay? 1 plus x squared to the negative 3/2 is what we end up with. Okay? Now, would that have happened on the red one? It would have. If we would have done that with Will's here, we have 2 sets, right? We would take out the smaller power, the negative 3/2, so we would have 1 plus x squared to the negative 3/2, and then what would be left? Well, here you had negative 1/2, you took out negative 3/2. Well, what's negative 1/2 take away negative 3/2? 1. So again, what would have been left here? A 1 plus x squared, and then minus, and you took this out, x squared, and look what happens. The x squareds cancel, and you end up with just that right there. Right? So Will's idea was fine, splitting it apart, but then you end up with this, which actually something could be, and the only reason factoring out was nice there is because this canceled. If this wouldn't have canceled, then the factoring was not a big deal. Right? That's the only reason. Okay? So that would be, so number 4 would be one that would have that kind of simplifying I'm talking about. Right? And like I said, there could be 1 on there, or 2 maybe, but there isn't going to be 6 of them that have, and even that negative, that was really hard, because we hadn't hardly done that at all. So chances are that won't be on there at all, right? The negative, taking out a negative fractional power, It might end up being a little simpler. Let me see if I can make one up that would have something a little easier. Again, we tend in class here to focus on the harder ones, right? There's going to be some that are a little simpler than that too. And hopefully if you've been doing enough practice on this page or on the website, once you notice that there's a fair number where you can just kind of go through and do pretty good on. Okay, so let me give you one here. Let's say we had, let's say e to the 3x. Over x squared. Try that. Try that. right, so don't look up here if you don't wanna see this. So you agree with the top part I got there, right? Top derivative, so you kick out 3x squared left alone, minus e to the 3x left alone, times the bottom is 2x, all over the bottom squared. Well, what can you do on the top? You can factor out well, now, yes, you can factor out e to the 3x, I'm fine if you do that, but you don't need to because there's nothing to cancel it with, right? But what you really want to factor out is what? An x, because there's something down there to cancel. Now, if you go ahead and factor out an x and an e to the 3x, okay, which you would a lot of times think to do, you'd be left with what? 3x minus 2, and then down here you'd have x to the 4th, and then cancel, change that to a 3, right? So that's not bad. I mean, they're not going to be as messy. I mean, that was tough, right? I mean, but it might be just that, right? Now, if you didn't take out e to the 3x, I'm okay with that too. And splitting it apart would have been good here, right? Split that apart, and you could have canceled there, and that would have been okay as well.
So 3 to the 3x over x squared minus 3 to the 3x times 2x over x.
Like that, and then 2e to the 3x over x cubed.
Yeah.
I'd be good with that. Yeah, I'm fine with that. Okay. Here's the only. I think, Will, in the future, the only reason I don't know that I would be in a big hurry to split those up is when we do the derivative and want to set it equal to 0. It's better to have a single fraction equal 0. Because when does a single fraction equal 0? When the top is 0. Setting this equal to 0 and trying to solve would be a lot harder. Or would be more complicated, right? So I'm not sure I would get in a habit of wanting to split it all the time, right? I think I would probably do this more often, okay? But if we'd only taken out the x, then you'd have had 3x e to the 3x minus 2e to the 3x all over x cubed, and then that would have been a good version as well. But you could have factored out, like Jesse factored out the e to the 3x. I'm fine with that. There just wasn't anything. Okay, so that there could be that kind of cancel, right? There might be something like that, which is just not too terribly difficult. But, okay. All right. Anybody else have one? Something they want to look at. There's just tons of them on there.
Did you say that our secant arc stuff is going to be on the list?
Whatever's on this derivative rule page.
Will we have any other like arc secant or arc?
Not arc secant.
Okay.
Arc sine, arc cosine, arc tangent. Just these three. Just what's on this page. And don't forget about secant, cosecant, here, and cotangent, tangent, Don't forget about those rules. The little asterisks I put by them are just like, hey, you probably should look those over because they don't happen a whole lot, and so you just got to make sure, because you'd hate to get to an easy one, which I would consider a really easy one. If I just give you y equals secant of x squared, right? Well, to me, that's a real easy one. That should be a real easy one. What's the rule? This is secant u we're looking at, right? What's the derivative of secant u?
Secant u times tangent.
Secant u times tangent u times u prime, right? So this is simply going to be secant x squared times tangent x squared, and then times 2x, right? It's secant u times tangent u times u prime. So secant x squared times tangent x squared times 2x. And that's it. You don't have to do anything else, right? So to me, that would be, that's an easy one. That's an easy one. Okay? So we don't want to miss the easy ones because we didn't look over the rules. Right? Get too caught up in all this fancy simplifying and all that stuff, worry about that, which is you want to be able to do, but gosh, make sure you can do those. Okay? How about on the websites? I haven't done a ton on this page before. Geez, look at all these different tests. This is test 6. Assuming they get a little harder as you go along.
What was the first one?
That's a 3.6.
I exited 3.6.
Yeah, I don't anticipate doing that. I would be more in the fractions, but right, I mean, that just, you bring down a 3.6 and it'd be x to the 2.6, right? You just drop the power by 1. Now, I definitely will have some fraction powers on there, like x to the 5/4, make sure you subtract fractions, and that kind of, for sure. Let's see.
2.7.
E to the, yeah, you're going to kick out a 2.7, right? But e to the 2.7. It doesn't look like this one has any, implicit differentiation is kind of what I'm saying. So I was going to look for some of those. Let's go with this one. I've done quite a few on this one. Okay, here's a good one. Let's go through some of these. Now, let me know if you've done all these, and want to just practice some more while we're doing this. If you want to practice some more on page 195, go for it. But try that one. Try that one, if you haven't already done this one. See, to me, this would be kind of a middle of the road one. It's got that 3 exponential. We see E a lot more than that. It's got some little stuff in there, but there really isn't any simplifying. It's just knowing the rules, right? It's just knowing the rules. So it's, and so when I say middle of the road, for example, you could probably expect some. We're not spending much time doing them, but You know, to me, that's if we talk about easy ones on the test, that's an easy one right there, right? I mean, just power rule, you know, or just sine of 3x, you know, maybe, or something. You know, I don't know if it'd be quite that easy, but maybe sine 3x plus e to the 4x, or, you know, whatever. So there'll be a few of those on there, you know, that, to me, though, we're not spending much time practicing those, but those are, you know, those are your basic, just kind of know the rules. So this one's a little more in the middle of the road. So, Skylar, this is a product rule, right? This is like the one you were asking about, right? Chain rule versus product rule. So it's two things multiplied. So there's your u, there's your v, right? So we're looking at u prime v plus uv prime, right? So, what's the derivative of 4x to the negative 1? Negative 4x to the negative 2 times this left alone, right? So there it is, negative 4x to the negative 2 times this left alone. Now I put parentheses around that. And then plus, and then u, which is just 4x to the negative 1 left alone, times, and then there, so there's u prime, there's v, there's u, and here's v prime. But right, ln3, don't forget that. Okay, go ahead, Jesse, say. Yes. Everybody notice that here at the end? That is wrong, wrong, wrong. That 2x minus 1 is wrong, wrong, wrong. So we got 3 raised to this times the ln3 times the derivative of the inside, right? The u prime, if you will. 2x minus 1. That has got to be in parentheses. Otherwise, you're only multiplying by the 2x and then subtracting 1 after. And that's not what we want. That's got to be in parentheses. Now, again, nothing that can be simplified. Nothing at all here that can be simplified. You cannot take that 4 times that 3. Okay, that 3 is raised to a power. You cannot take 4 times 3 and get 12. It doesn't work. I mean, again, simple little example. 2 times 3 squared. Right? That's 18. Right? 2 times 3 squared is 18. That is not 6 squared. It's not 36. Right? So you cannot take that 4 times that 3, or that 4 times that 3, or whatever. There's really nothing to do. Could this 4 distribute through those parentheses? Yeah, but why? Don't bother. So it's just rearranging. So none of these, so that's it. That's it. Just a straightforward product rule. The chain rule thrown in there too. Okay. All right, let's see what else we got here. There you go. Do that one. Little implicit differentiation there. Implicit differentiation. All right, what's the first line look like? 2y prime
2x
equals 2x
plus cosine y times y prime.
cosine y times y prime. Perfect. 2y prime equals 2x plus cosine y times y prime. Okay? And then, because remember the rule is when you take the derivative of a y, you do the normal derivative, tack on a y prime.
Isolated the y primes.
So you isolate the y primes, which would mean I subtracted it that way. Doesn't matter. But I already had that 2x sitting over there on the right, so I thought, well, I'll just leave it there. And let's move the cosine y prime over. And it's important, it's important, and notice they just put sine y. I want parentheses around that because you got the cosine y goes together and the y prime is, you could stick the y prime in front of the cosine y, maybe that'd be better. So whatever. So you take out y prime, so you get 2y minus cosine y, and then you divide. So you get 2x over 2y minus cosine. Right? Going to be a few of those.
Wait, why does the y stay with 2?
What?
Why does the y stay with 2?
It doesn't. I was just, like that last one, I was just checking, just testing it. Good job.
So,
Looks like now I get a 90. I get a 90. I still pass.
We still
So-
get it.
2x over cosine y minus 2 is right.
Say that again.
2x over cosine y minus 2 is right too, isn't it?
It'd be negative 2x.
Yeah.
Negative 2x over cosine y minus 2 would be correct also. Because that'd be if you move that negative, the 2x over there, and then these over here, they'd be reversed, yes. So that would be good also. Okay? Alright, yeah, good catch. Seems like they don't have any. Now here's kind of a strange one where I'm not going to give you a y prime like that, where there's a quotient rule, but definitely could have this one. This is similar to one we did when we did this section, so why don't you go ahead and try it out. And remember, hint, right here. Right, on this first thing. Right? What's my hint? What am I getting at? Product rule. That's a UV. So you gotta do a product rule on the back. Not on anything else, but when you got an X and Y together, multiplied together, you gotta do a product rule. And several of the ones we did in class last week, that's what we had, so. Okay, I'll uncover my first line, see if you want to check that anyway.
All good there? So derivative of x squared is 2x, leave the y cubed alone. Now, notice where I put the 3. This always drives me nuts when people do this. So when you go x squared, so derivative of the first 2x, leave the y cubed alone. Then, when you leave the x squared alone and you do the derivative of y cubed, you get 3y squared y prime. Don't put that 3 in the middle there. Yeah, you can originally when you just do it, but don't leave it there, right? I mean, if we had 3ABC, we wouldn't write it A3BC. You know what I mean? It just looks strange. Don't leave that there. Put it out front, especially if there's already another number out here. You want to multiply that together. So when I did that, I just went ahead and threw it out in front right away. Okay? Anyway, and then this, remember, 3y squared, the normal derivative is 6y, and then a y prime. However, when you do the 4y, the derivative is 4, and then you tack on the y prime. So there's a difference between those two there, so make sure you see that. And the same thing, again, with the y cubed. It's 3y squared, and then a y prime. All right, so then I had 2y primes over here, so I just brought the 4y prime over with it. I subtracted the 2xy cubed over there. So I got 3 things with y primes in them. So I take out a y prime. I got those 3 things. I got this over here, and then I just divide. That you want to be able to do for sure, right? I mean, that one, and like the last one we did, though, that's pretty much what it's going to be with implicit differentiation. Maybe a product rule, but not a quotient rule like that other one was. Don't have to do that. Okay?
Why don't you want us?
It doesn't like this one. I mean, because we don't run into those very often. The implicit differentiations we run into are typically pretty straightforward with x and y's. They're not that good.
It's just 2 product rules. 3 product
This would be a 3 product rules, yeah. Be 3 product rules. And you know, it'd just be messier algebra. We got enough problems where we might run into messy algebra, but not with implicit differentiation. We're not going to. So we'll just stick with the basic part of that. That'd be a product rule. And then, again, that's kind of like that number 21 we did in class that had we had to FOIL everything out. It was just hard to get the y primes on one side. So we're not going to do that. But, let's see. We got a little bit of time left, not a lot. So let's just practice a few. Yeah, it should be really that should be just kind of straightforward. You know, while you're doing that last website we went to, the derivative 3, you know, it has 8 of them. You know, those are a little simpler, but that's good practice to do for tomorrow. Get your confidence up, number 1. And number 2, it's just good practice on the basic rules. And you don't get caught up in all the, you know, simplifying and all that kind of stuff. And so if you're really solid on your basic rules, you know, that just is good. So I think that's some good stuff to practice. And this is a fairly basic one. Another example of not a lot of simplifying or anything.
How come, like, if, like, the x was just 3, and since the derivative of the number is 0, how come that doesn't cancel out when we tack onto the u prime?
Well, now remember, it's if you just do the derivative of a number by itself, the derivative of that is 0. But if you have a number times a function, you know, the number just stays there as you do the derivative. You know what I mean? Only if you're doing the derivative of a number, you do that. So I guess I'm not following your question on this one.
Okay, so it would be 1 over the square root of 1 minus x squared. But if that was like the x was a 3 times.
Oh, well, that's a whole different thing. If that said arc cosine of 3,
It's just a
then this whole thing is just a number. Then the answer would just be 0.
okay.
Yeah, a 3 versus being an x is totally different, right? Yeah, ln x, the derivative is 1 over x. ln 3, the derivative is 0 because it's just a number. Yeah, big difference. So the x is the key. And of course, that's what we're doing the derivative with respect to, right? We're doing the derivative with respect to x. Okay, so I got this right here, and there's really nothing to do other than, could I probably throw this on top, especially that 3, and the negative, I wouldn't mind seeing that go together. So you got this, right, the arc cosine is squared, and then all over square root of 1 minus x.
Do you care if it's the squared by the cosine and the normal for function?
In here, yeah, I don't know that I ever see it that way with arc cosine, but I guess it would be.
That's fine. You notice they didn't write it that way, but I guess it could be. Does that make sense? So it's a u cubed, so we're bringing the 3 down, we're leaving that alone, dropping it to a 2, times the derivative of our cosine, which is just that. That's it. That's it.
So just knowing those basic rules is not all bad. That's one where you're going to have to kick out a -1 because the derivative inside, or else you can kick out an ln 10, because the derivative of 10 raised to something, so just knowing your basic rules. Here's one of those kind of trick ones, right? What's the derivative of pi squared? 0. Plus pi squared, that's just a number, so the derivative of that. Now here you're going to have, a product, right? What's the derivative of x squared? 2x times 2 to the x left alone, which you can't put those together as much as you'd like to, plus x squared left alone times 2 to the x times ln 2. And then the pi squared, that's just going to be plus 0. And again, there's nothing you can put together. Right there. So again, it's just basic rules right there. So those are good ones to practice, even though we've run into some ugly, kind of messy ones from time to time here. Chances of you needing those. And then the solutions, of course, are all there. This is the place to go for some of those implicit differentiations. Not a lot of great places to practice. We already did a couple of those, but like I said, you can just make them up too. If we go back to number 3, any of these all seem to be pretty equal in difficulty. On that last website, they get a little harder as you go down, test 1, test 2, test 3. These all seem to be pretty basic. But, again, this page is not a bad one to go to. I mean, there's a nice, that could be simplified actually right away, right? Here you split this apart, couldn't you? X cubed over x squared is x over x squared is 1 over x. This would be x plus 1 over x. You can just simplify that. But you can do a quotient rule on it and see, and it would simplify as well. Here's a good one where you want to make sure and write that as cosine of x squared plus x all to the 4th, right? We got just enough time to finish this one. So that would be that one. So you guys tell me. So you first write it like this, then what? Bring the 4 down, leave all this alone. To the 3rd. You don't forget that. Every year there's something like this, and somebody misses it because they forgot to put the 3 there, right? So don't forget that. Times. Now you're doing the derivative of that, which is negative sine. Make sure you have a good dot here, or you put parentheses, which wouldn't be a bad idea here, because we're going to have a bunch of stuff here, looks like. Oops. I don't know what just happened. Okay. Negative sine of x squared plus x times better get parentheses around, right? I did that on purpose. Around the 2x plus 1, right? So that's inside and then another inside, right? It's not a product rule, but it's inside and then another inside. So 4 cosine of this to the 3rd, then times negative sine of this, and then times the derivative of that inside, which is 2x plus 1. Now what can we put together? This negative could go out there, because basically what do you got? You got this thing, times this thing, times this thing, times this thing. I mean, they're all times. They're all this, 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 this. So A, B, C, D, you can rearrange that. So the negative I can pull out front, put there, but otherwise the rest of it is just. So it turned out I really didn't need this parenthesis here and this parenthesis here, because this thing is in parentheses, this thing
you know, but, I can handle it, it doesn't matter if you have extras. Okay? So, there's a lot of good, just basic practice ones, but just doing it so you're not, even though you think, oh yeah, I got this, but it's so easy to make little mistakes. The more you practice them, the chance, your chances go down of making those little mistakes. And then again, if you don't pass it on this first time, then you got to be thinking about it while we're going on to new stuff too, and trying to get a better grade on.
How are we gonna do the end of this semester? Are we just gonna end a bunch of chapter tests?
Just a quiz. Just gonna be a quiz. We're gonna do, we won't do a semester final, because that's our midterm next February. We have 3 terms, so it's like a term and a half. Is kind of the plan. So basically what we have left is we have this gateway test, grade. We're gonna have, I'll put in a homework grade here at some point, towards the end. Tomorrow afterwards, I will packet of problems with motion and derivatives, velocity, position, acceleration kind of stuff, just some review kinds of ideas, that you'll work on for Wednesday, but then, and we'll go over that a little bit Wednesday. Wednesday, we'll start chapter 4. We'll get through sections 1 and 2, probably do a quiz on those Wednesday, and then extra credit day on.
Oh, yeah.
Can I sing early, it's gonna be gone.
Oh, yeah. You're gonna be gone Wednesday on Thursday?
Yeah,
So you're gonna do that on Tuesday. When are you gonna do it on Tuesday?
take a test.
Yeah.
I might take it Monday in here, unless I can do.
Gee, Christmas, that's pretty early, Will. That's gonna be tough, because we won't have covered.
Oh, then I'll take it Tuesday. I can take it Tuesday during break time, because I don't.
Wait, when are you gonna be out?
But,
Wednesday.
yeah, then, again, the difficulty would be having enough time Tuesday during birthday time.
Well, when we get an hour, I don't think I can stay for lunch.
Oh, yeah. Well, as long as you're not concerned with eating lunch, maybe.
I'll bring my lunch.
Bring your own.
You'll have the answer for your comments.
We'll figure it out.
Alright, my name is.
So everything's in mustard.